All right, today we're going to look at a really cool breakthrough from Stanford University that could bring helpful robots into our homes way sooner than you might think. Let's dive into the story of Mobile ALOHA, a robot that actually learns by doing. But before we get to know this robot, let's kick things off with a question. And I'm pretty sure it's a question that's crossed your mind at some point, maybe while you were staring down a mountain of dirty dishes. I mean, seriously, the dream of a household robot, a real Rosie the robot, has been a part of science fiction for decades. So what's the holdup? Well, it turns out the answer is kind of complicated, and it all starts with one big, fundamental problem. So the first major hurdle, it really has to do with a huge limitation in how most of these advanced robots learn. They are, for the most part, completely stuck in one place. Think about it like this. Most of the high-level robot learning we see happens with these robotic arms that are literally bolted to a table. Now, they can get incredibly good at very specific, delicate tasks, but our homes aren't just one giant tabletop, right? For a robot to be genuinely useful, it needs to be able to move around, to get from the kitchen counter to the living room to the laundry room. And that huge gap between learning in one spot and moving around in the real world, well, that's the key challenge right there. So to try and solve this problem, researchers at Stanford basically decided to start from scratch. They set out to build a whole new system from the ground up, and they were tackling not just what the robot could do, but also something incredibly important: its cost. And here it is. This is Mobile ALOHA. It's bimanual, which is just a fancy way of saying it has two armors, like us. It's a mobile manipulator that's designed to be super capable and also, as you're about to see, surprisingly affordable. So the big question is, how does it learn? Well, a human teaches it using a method called whole-body teleoperation. Now, this isn't like playing a video game with a joystick. This is way cooler. The operator intuitively guides the entire robot, the mobile base, both arms, all of it, at the exact same time. And this is what that actually looks like. The human operator is literally tethered to the robot. They move their own arms, and the robot's arms mimic them. They walk around, and the robot's base drives around with them. This allows for this incredibly direct, natural way of collecting data for complex, coordinated movements. Okay, so what do you think a system this advanced actually costs? Are we talking hundreds of thousands of dollars? Maybe $1 million? Get this, the total cost to build this entire thing is just $32,000. And that low price tag is a massive part of this story. By making the hardware so much cheaper than other systems, which can easily top $200,000, the Stanford team is basically throwing the doors wide open for more labs and more researchers all over the world to get involved in this kind of work. But it's not just about the cheaper hardware, as cool as that is. It's also about a much smarter way to learn. See, Mobile ALOHA has a very clever trick up its sleeve because it doesn't have to learn everything from scratch. The secret sauce here is a technique called co-training. The researchers found that if they combined a whole lot of existing data from older, stationary robots with just a little bit of new data from Mobile ALOHA, they could get a massive, massive boost in performance. So here's how that recipe works. First, you start with a big pile of data from those old tabletop robots. Then you collect a really small number of new demonstrations, we're talking just 50 per task, with the new mobile robot. You train the AI on both of those data sets at the same time, and bam, the system learns these complex mobile tasks way faster than it ever could have on its own. So the really crucial point is this. All that dexterity the system learned from simple tabletop things, like wrapping candy, directly transfers over to help the robot do these dynamic, whole-body actions in the real world. Things like holding a wine glass perfectly steady with one hand while cleaning up a spill with the other. That is a huge leap. So okay, we've got affordable hardware, and we've got a smart, super efficient way for it to learn. The big question now is, what can Mobile ALOHA actually do? Let's take a look. Well, for starters, it can get to work in the kitchen. Here it is, holding a pan steady with one arm while skillfully using a spatula to cook shrimp with the other. That kind of two-handed coordination is a gigantic challenge for most robots. It can also handle heavy objects. Check this out. It's opening a cabinet, and notice how it has to move its base backward as the doors swing out, and then it places a heavy pot inside. This is a perfect example of that whole body control we were talking about. It can even help tidy up a bit. Pushing in a chair seems so simple to us, right? But for a robot, that actually requires a surprising amount of spatial awareness and really delicate force control. And it can navigate our environments, too. Here it is precisely pressing a little button to call an elevator. That's a task that needs both long-range navigation to get there and then pinpoint accuracy to finish the job. And this one task really shows you the incredible power of co-training. When the robot's AI was trained only on those 50 new human demos, its success rate was zero, a flat zero. It failed every single time. But by adding in the existing data through co-training, the success rate shot up from 0 to 95%. That's just wild. Okay, so let's zoom out for a second and just look at the big picture. What does all of this really mean for the future of having robots in our daily lives? What Mobile ALOHA gives us is a really powerful blueprint. It proves that you can build highly capable mobile robots on a reasonable budget. It shows that this co-training idea makes learning dramatically more efficient, and it confirms that simply showing a robot what to do is a fantastic way to teach it complex, real-world skills. You know, at the end of the day, projects like this are about so much more than just cooking and cleaning. By making it faster, cheaper, and just plain easier for robots to learn, we're taking a real, concrete step toward a future where they can become genuine helpers and collaborators, both in our homes and at work. And all of this leaves us with one final fun thought. Once this technology is perfected and these robots are finally ready to help, what's the very first chore you would hand over?